Welcome to this explainer. Today, we're going to completely demystify how to build autonomous, production-ready AI systems right from the ground up. Look, if you've been working with language models, you already know they're incredibly powerful, right? But you also know their fundamental limits. While everyone else is out there hyping up basic chat interfaces, the real engineering challenge, and the real fun, is building systems that don't need constant hand-holding. So today, we're moving way past those basic limits to build real, functioning digital entities. Let's get into it.
So if AI is so smart, why on earth can't it remember what you said just 5 minutes ago? It is a highly frustrating reality, and quite frankly, a massive bottleneck for automation, that standard language models essentially have amnesia. You can engineer an absolutely brilliant prompt, but the system still forgets it all right away. Well, today, we're going to fix that. We're going to transform those isolated, forgetful scripts into robust systems that can actually think, act, and crucially, remember.
Okay, here is our roadmap for today. First, we'll look at moving beyond basic chatbots. Then, we'll break down the anatomy of an agent, figure out how to cure that AI amnesia, and explore the absolute power of giving our AI tools. After that, we'll talk about choosing your framework, and finally, peek into the multi-agent future. All right, let's kick things off with Section 1, Beyond Basic Chatbots, the Stateless Problem. So the crucial point you have to understand is that a basic model is completely isolated and stateless. It literally treats every single prompt as its very first. When you ask it a question, it processes that query completely independently. Your agent won't remember what happened 5 minutes ago unless you manually feed that context back in. Now, you might be thinking, hey, I'll just pass the entire chat history back every time. But honestly, blindly stuffing the context window with past interactions is a terrible strategy. It balloons your API costs astronomically, and worse, it degrades the model's performance because it completely loses the signal in all that noise. To automate serious workflows, like autonomous customer service or predictive maintenance, we absolutely have to solve this amnesia without just throwing tokens at the problem.
Moving right along to Section 2, Anatomy of an Agent: Brain, Hands, and Memory.
We need to stop thinking of an AI agent as just a simple script and start treating it like a dynamic entity. We are upgrading from a system that just mathematically predicts the next word to one that actually reasons, takes real action, and builds upon its past experiences. Honestly, it's the difference between a static encyclopedia sitting on a shelf and an active, brilliant research assistant working right alongside you.
What's really cool is how perfectly this maps complex code to a human anatomy metaphor. We have the core pillars of an agent. First up, the brain. That's your language model. It interprets the user's intent and plans out the next steps. But, a brain in a jar can't really do much on its own, right? So we have to give it hands. These are executable tools or Python functions that give the LLM the actual agency to change state, not just read it, like updating a database or firing off an email. And finally, the memory. Often powered by vector databases, this provides the rich, deep context needed to make truly informed decisions.
Which brings us perfectly into Section 3, Curing AI Amnesia, Stateful Systems.
Just like us humans, agents really need both a working memory for whatever immediate task they're doing and a long-term memory to remember past interactions. Technically speaking, short-term memory is usually managed as a pretty simple message array. It tracks those intermediate reasoning steps right within a single session, like, say, remembering a user's location while it's in the middle of booking a flight. But the catch? Once that session ends, the array is totally wiped. Long-term memory, on the other hand, persists indefinitely. Instead of basic arrays, it relies on vector embeddings. This is a total game changer because it allows your agent to semantically retrieve only what matters, remembering user preferences across weeks or even months without constantly hitting those massive, expensive token limits.
Let's break down exactly how this memory architecture works. This is essentially a 4-stage process that systems like Redis use to mathematically find and inject the right context. First, we have encoding, which converts your data into vector embeddings, basically numerical representations of semantic meaning. Second is storage, placing these vectors right into an index. Third comes retrieval, using clever algorithms like approximate key nearest neighbors to quickly find relevant context. And fourth, integration, where we format this data to augment the LLM's prompt. Now, the speed here is absolutely critical. A system like Redis combines that vector search with operational data storage, meaning these complex lookups complete in literally microseconds. And fetching semantic context that incredibly fast, that's exactly what makes real-time voice or chat agents actually viable in a production environment.
Okay, Section 4, The Power of Tools, Giving AI Hands.
Now that our agent has a memory, we need to give it the ability to interact with the real world using the REACT loop. REACT simply stands for reasoning and acting. Here's how it flows. If you ask your agent, what's the weather in Tokyo in Celsius, the model first reasons that it needs to find the weather. It selects a weather tool, executes it, maybe it gets the answer back in Fahrenheit, then it reasons again that it needs a calculator tool to convert that to Celsius, and finally, it returns the finished answer to you. The major breakthrough here is that you don't have to hard code this routing. The LLM decides step by step, dynamically on the fly. Now, a quick word of caution here, while the REACT loop is incredibly powerful because it prompts the model at every single step, it can definitely be highly token-intensive.
So what do these tools look like? By providing structured schemas for tools like a weather lookup API, a Python calculator, web scraping scripts, or even database SQL querying, we let the LLM decide totally on its own when it needs to reach out and grab external data. To the LLM, a tool is literally nothing more than a JSON schema describing its name, its purpose, and its required parameters. The real magic under the hood is just standard OpenAI function calling. The exact moment you wrap a simple Python script inside a tool schema, your framework describes it to the model, and the agent reads that description to choose exactly the right tool for the job. It's brilliant.
Moving on to Section 5, choosing your framework. Assembly required. With the anatomy understood, you need a framework to actually assemble these pieces in code. And you're going to face a critical trade-off right away: control versus speed. Let's look at the options. LangGraph models agents as nodes in a directed graph. You get explicit, strict control over every state transition. It's basically a complex state machine built for enterprise. Incredible for production, but yeah, it has a higher setup cost. Then there's CrewAI, which abstracts all that away into role-based setups. It's super fast if you need to ship a linear workflow quickly, but can be much harder to debug. And finally, AutoGen is fully conversational. It relies on message passing between agents, which honestly often feels like a chaotic but completely brilliant group chat. It is absolutely fantastic for research prototypes.
Now, a super important best practice to keep in mind. Mixing CrewAI for one subtask and LangGraph for orchestration might sound like an elegant, cutting-edge microservices architecture, but in reality, it is a fast track to debugging hell. Mixing frameworks in production just creates massive operational complexity and token overhead. So, feel free to prototype in whatever framework you want, but absolutely standardize on one early for production. Save yourself the headache.
All right, our final section, number 6, the multi-agent future, teamwork.
Let's scale this whole thing up from a single digital entity to a full-blown corporate team working together. By breaking complex tasks down, we can have a manager direct a strict judge and a thorough analyst to produce just incredible research. Now, you might be wondering, why don't we just use one giant prompt for everything? Well, because smaller, highly specialized prompts hallucinate way less and perform infinitely better. Separation of concerns is absolutely key here. For example, in a system using the OLA-Step API, the manager agent doesn't even try to answer from memory. It just orchestrates. It gets an initial answer, passes it to the judge agent, and the judge is strictly instructed to reject any vague answers. We're talking a required quality score of 0.85 or higher. Only when that judge gives the green light does the analyst agent step in to write up a clean, structured markdown report.
Just notice how beautifully this progressive workflow prevents wasting compute resources. It perfectly balances speed, cost, and accuracy. Simple questions finish quickly and cheaply. But if a question is complex and the judge rejects that initial answer, the system doesn't just fail, it routes back. The manager agent will then dynamically spin up deep, expensive web search and scraping tools to gather much better evidence, and then it tries the judge again. It's incredibly efficient.
I want to highlight this quote. AI agent memory turns stateless language models into systems that remember past interactions and build on experience. This right here is the massive paradigm shift we are taking. By combining a language model brain, functional tool hands, and persistent vector memory, we are no longer just talking to isolated chatbots. We're deploying capable, experienced systems that can actually execute complex, multi-step business workflows with just incredible reliability.
So now that you've got the blueprint for brains, hands, and memory, the really exciting question is, what workflow are you going to automate first? Is it going to be a customer service agent that seamlessly remembers user preferences across every single channel? Or maybe a multi-agent research team that scrapes and analyzes complex financial data entirely autonomously? And perhaps more importantly, as these multi-agent teams become cheaper and faster than human teams, how is your own role going to change? The tools and the frameworks are out there and ready. It's time to start building.